In this video, we're going to discuss finding a basis for and dimension of the solution space of the homogeneous system of linear equations. Let's consider the following homogeneous system of linear equations. We'll begin by writing the system in matrix form so that we have the coefficient matrix and, using either row operations or technology, we'll convert this coefficient matrix to reduced row echelon form. I used a TI-84 graphing calculator to find the reduced row echelon form. If you're not familiar with this method, you can obtain the reduced row echelon form of the matrix with the following commands on the calculator. Second, matrix. Then you'll highlight Edit and press Enter. You'll set the matrix size, which in this case is a 3 by 4, since we have 3 rows and 4 columns. You'll enter the coefficient values row by row. Then you'll press Second, Quit to exit the matrix screen. You'll go back into Second, Matrix, highlight Math, and you'll scroll down to RREF, press Enter, then Second, Matrix, and assuming you put your values into matrix A, you'll type the letter A and press Enter 2 times. This will give you the reduced row echelon form of the matrix. Which is in row 1, 1, 0, 4, 3, row 2, 0, 1, 1, 2/3, and row 3, 0, 0, 0, 0. Next, we'll write the system of equations that corresponds to our reduced row echelon form of our matrix. That would be x1, or x sub 1, plus 4 x sub 3 plus 3 x sub 4 equals 0. And then for row 2, we have x sub 2 plus x sub 3 plus 2/3 x sub 4 equals 0. Here we have to let x3 x sub 3 and x sub 4 be free variables. And we'll call them S and T. So that for our new equations, we have x sub 1 equals negative 4s minus 3t, and x sub 2 is equal to negative s minus 2/3 t. Where x sub 3 is equal to s, and x sub 4 is equal to t. We can write this as x equals s times column negative 4, negative 1, 1, and 0, plus t times column negative 3, negative 2/3, 0, and 1. And we can conclude that our basis is negative 4, negative 1, 1, 0, negative 3, negative 2/3, 0, and 1. To find the dimension of our solution space, we consider the following definition. Given that A is an m by n matrix of rank R, the dimension of the solution space Ax equals 0 is n minus R. We consider our original matrix. We see that n is equal to 4. And when we consider this matrix in reduced row echelon form, we find that the rank R is equal to 2. Therefore, we can conclude that the dimension of the solution space is 4 minus 2, which is equal to 2. So this concludes our example on how to find a basis for and dimension of a solution space for a homogeneous system of linear equations. I hope you found it helpful, and we'll see you next time.